So let's rewind the clock for a minute. Before we were all swiping and tapping on glass, our digital lives were ruled by something else entirely. We lived in the kingdom of keyboards and mice. Think about it. Those chunky beige keyboards with the satisfying clack, clack, clack of every keystroke. The ball mouse that you had to pop open and clean every few weeks. These were our original gateways to the digital world. They were functional, sure. You could type out a document, navigate a spreadsheet, or click on an icon. They got the job done. And for a long time, that was more than enough. These tools were revolutionary in their own right, translating our physical actions into digital commands with a level of precision that was unheard of before. But here's the thing about technology. Good enough is never the end of the story. As computers became more graphical, with folders and icons instead of just lines of code, a gap started to form. We were still interacting with this vibrant visual world through these indirect tools. It was like trying to paint a masterpiece with a remote-controlled robot arm. You could do it, but it wasn't natural. You had to learn the language of the machine. Control plus C to copy, double-click to open. There was always this layer of translation between what you wanted to do and how you actually did it. The human brain is wired for direct interaction. We point at things, we grab them, we move them. The keyboard and mouse were a brilliant workaround, but they were still a workaround. This craving for a more intuitive connection wasn't just a nerdy dream. It was a fundamental desire to make technology feel less like a tool and more like an extension of ourselves. Why should we have to learn a complex set of commands to interact with a machine? The very first attempts at making a touchscreen weren't exactly sleek or elegant. We're talking about the 1960s and 70s here, a time when computers filled entire rooms. One of the earliest pioneers was a guy named E.A. Johnson, who worked at the Royal Radar establishment in the UK. His early work described a capacitive touch system. We'll get more into that later, but it was mostly for air traffic control. Imagine these huge, bulky CRT monitors with a grid of invisible beams or wires overlaid on top. Breaking a beam with your finger would tell the computer where you were touching. It was basic, but it was a start. It proved that the concept of direct interaction was possible, even if the tech was still in its infancy. These early systems were not for you and me. They were for specialized, high-stakes jobs. Think power plant control rooms, military applications, and complex academic projects. At the University of Illinois, the Plato 4 computer terminal, released in 1972, had an infrared touch panel. It used a 16 by 16 grid of infrared beams just in front of the screen. When your finger touched the screen, it blocked a horizontal and a vertical beam, and the computer could calculate the coordinates. It was incredibly innovative for its time, allowing students to answer questions by simply touching the screen. But it was expensive, not very precise, and prone to errors if a fly landed on the screen. As touchscreens started to get a little more common, two major technologies emerged, and they fought a long battle for dominance. This was the Great Divide, resistive versus capacitive. You've definitely used both, even if you didn't know it. Let's start with resistive. A resistive screen is all about pressure. It has two flexible layers separated by a tiny air gap. When you press down on the top layer, it touches the bottom layer, completing a circuit at that exact point. The device then calculates the coordinates of your touch. The key word here is pressure. You could use your finger, a stylus, a pen cap, or the corner of a credit card. It didn't matter what you used, as long as you could press hard enough to connect the two layers. Resistive screens were cheap to make, and they were everywhere for a while. Think about those early PDAs like the Palm Pilot, the Nintendo DS, or those credit card signature pads at the grocery store checkout. They all used resistive technology. The upside was that they were inexpensive and worked with any object. The downside, well, they didn't feel great. The screen had a slightly soft, plasticky feel, and you really had to push. They weren't very sensitive, and they couldn't handle more than one touch at a time. Plus, that top plastic layer could get scratched or hazy over time, making the screen harder to see. It was a functional solution, but it wasn't the premium experience we know today. Then came capacitive technology, and it changed the game completely. A capacitive screen doesn't rely on pressure. Instead, it has a layer that stores an electrical charge. Your body is also conductive, which means it can hold a charge. When your finger gets close to the screen, it disrupts the screen's electrostatic field at that specific point. The device's processor instantly calculates the location of that disruption and registers it as a touch. It's detecting the conductive properties of your skin. This is why you can't use a capacitive screen while wearing regular gloves or with a plastic pen. They don't conduct electricity. It needs that direct skin contact. Capacitive screens were a massive leap forward. They were way more sensitive and responsive than resistive screens. You only needed a light tap, not a forceful push. This allowed for a much smoother and more fluid user experience. Since the top layer could be made of glass instead of flexible plastic, the display was brighter, clearer, and much more durable. The first iPhone in 2007 was the device that really put capacitive screens on the map for the mainstream.